Hello everyone, this is the second lecture of the course and I'm going to talk about free and open source software for Geospatial, or as it gets called, FOSS4G. And I want to have one little mention about the first class exercise. There was a question in there that asked you if you knew the difference between what open standards versus open source software might be. And I didn't expect you to necessarily know the answer to this. This is just a way for me to kind of get you thinking about this and see if you had any thoughts about it or had heard of these terms. So just to cover that, I think most of the other questions on the first class exercise are pretty straightforward. But open standards are specifications for file formats or interfaces or communication, like communication across the internet for interoperability. So HTML, for example, is a standard. And KML, the file format, is. And ways of streaming base maps are also standards. So standards are protocols for file formats or communication. And an open standard is simply one that's been developed in an open forum where everyone can participate. And we can contrast that with open source, which refers to software that's licensed in a way that grants the end users rights or freedoms and access to the source code. Open source software typically follows open standards, such as QGIS, as you'll see. So I just wanted to cover that. So why use open source? Well, first of all, obviously, GIS is just a tool. So why not have a full toolbox? You usually don't limit yourself to just having one screwdriver. So why limit yourself to just having Esri software? Open source is also accessible. You can install it on almost any operating system typically, and it's affordable. It's stable. It follows open standards, which Esri doesn't always do. So the more a software follows open standards, the more interoperable it's going to be. You can have GIS on multiple operating systems. For example, if you're a Mac user, most open source software will run on it natively, unlike Esri software. You can have more direct involvement in the development. If there's a new feature you want, you can literally contact a developer, even if you're not going to program it yourself, get an estimate for that, and have that new feature in the software within a few weeks. You can eliminate licensing fees and build stronger communities. When you first download QGIS and start using it, you're going to become part of the QGIS community. So what's out there? Well, there's a lot. There isn't just one source for geosolutions anymore. And today I'm just going to introduce a couple of the leading packages. There's hundreds of them. I'm just going to introduce you to a few. So this will be quite a bit of material. I don't expect you to know every single one of these applications. I'm really only going to hold you responsible for the ones we use in class. But here I just want to introduce you to the huge world of geospatial applications that are out there way beyond the Esri sphere. So there's a lot of slides here, but I'm going to go through them fairly quickly. I'm going to link to this video in the module directly so you can watch it. It's about a 20-minute video, and it's a keynote talk at a FOSS4G conference by this gentleman, Paul Ramsey, who's a leader in the open source software world. And it's a really good talk because I think a lot of times it's kind of counterintuitive to people, especially living in a capitalist society. If the software is so good, why give it away for free? Usually people think, you know, the more you pay, the better it's going to be. And that's not necessarily the source here. And people have questions on how to make a business around open source. And so Paul Ramsey here addresses that. And it's an interesting talk, so I really encourage you to listen to that. I think it'll start making more sense as you watch some of these videos. So when we talk about open source software, there are different realms. There's desktop software like using ArcMap. There's just geoprocessing and analysis, which you don't necessarily even need to open up a graphical user interface to do. You can do some of this just with Python or in a database, for example, which leads me to spatial databases. This is going to be an interesting topic this semester because spatial databases is something that the ESRI world is kind of lean on, and you're going to really see some of the true power of a real spatial database in this course. There's also web mapping servers and web mapping clients. We're not going to talk about those until the second half of the semester. Today we're going to really focus on the desktop packages and geoprocessing tools. So often software will get grouped by the language it's programmed in. So there's the C or C++ tribe, Java tribe, and the .NET tribe. I'm going to start out with some foundations. There are some what we'll call a library, which is software that's basically just a bunch of utilities that you can use to do something. And there are some really important foundational pieces of software like this that underpin almost all the open source projects, and a lot of these, as you'll see, even get used by Esri. So one that we're going to talk about a lot is Goodle and Ogre, or you might say GDAL and OGR. It's up to you. This is a set of tools first developed by Frank Warmerdam. It's now governed by a project steering committee under this man, Evan Raoul. And these are tools for reading, writing, and processing data. So this is how QGIS, for example, can read and write so many formats, because it has Goodle underneath the hood, which allows it to read all kinds of raster formats. Then it also has OGR, which is the counterpart to GDAL that reads vector files, reads and writes vector data. So alongside with Goodle and Ogre, there's another software project called ProjFor. And ProjFor is simply tools for reprojecting data. It allows you to take something from UTM and convert it to state plane. So going into OGR a little bit more, OGR is again tools for manipulating vector data. And OGR currently supports over 70, almost 80, I think now, vector data formats. So on the right hand side, you can see some of the common vector formats that OGR supports. So you'll recognize some of these: Esri Personal Geodatabase, Esri Shapefiles, GPX, KML, things like that. So a lot of the common formats it reads and writes. So that means that QGIS can read and write those as well. It also comes with some command line utilities, and we'll look at these in class in a few weeks. So these are, you can run the command ogre info and get information about a data set. And so you're probably not used to working in a command line environment unless you've worked with Python or something like that, but it can be a very powerful environment. These utilities can also be used in a programmatic sense, put into use in a Python script, for example, to do something to a bunch of data. GDAL is tools for manipulating raster data, and it supports over 100 different raster formats. And the URL is here, so if you want to go visit the page to see what formats it supports, I encourage you to do that. But here's a sample. So all the common ones that you may have encountered, like ERDAS Imagine Images, GeoTIFFs, coverages, things like that, are all going to be supported. GDAL also comes with command line utilities. It has quite a few more. Some of these are for creating shaded relief or contours from a DEM, or reprojecting an image, etc. And again, you can visit this URL to see what some of these commands do. And then there's ProjFor, and this was originally developed by the US Geologic Survey. It's since been open sourced and it's maintained by a gentleman named Howard Butler. And this is the engine for reprojecting data sets. And this gets used by every open source project, and even some proprietary ones like Google Earth, for example, uses ProjFor as well. ProjFor uses Wellknown Text, which is, if you've ever opened up a PRJ file in a text editor that has the projection information, that's Wellknown Text. So it's just a textual representation of the coordinate system. In the open source world, you'll also find that spatial reference system, SRSs, are often referenced by codes, EPSG codes. And that's simply a number ID for every unique coordinate system. So for example, UTM Zone 12 NAD83 is EPSG code 26912. Usually you're only working with a few coordinate systems, and once you know the codes for those, it can be a very quick way to just find them. And you'll note this is the spatial reference properties window from ArcMap, And you'll notice that it also uses these EPSG codes. So you will see these um, in lots of different GIS softwares, but they'll be more prominent in QGIS when we start using that. And there are some websites you can visit to look up EPSG codes if you need to find the code for a certain projection, for example. EPSG.org or spatialreference.org will help you do that. This is what a string of well-known text looks like for a UTM projection. And it's simply the projection is UTM, the zone is 13, the ellipsoid is GRS 80, and then it doesn't have any other parameters. So this projection, UTM zone 13, can also be referenced by the EPSG code 26913. So we're going to go through some desktop packages. I actually think I scratched UDIG. We're not going to talk about that. You can Google it. But these are some of the leading desktop GIS packages. We'll start out with this one called GIS. And this is really kind of the grandfather of open source GIS. It's the oldest active package. It was first started in '82, so it's almost as old as ArcInfo. For the development history, it was started by the U.S. Army Construction Engineering Research Lab. It was then revived by Baylor. It's kind of gone through peaks and valleys of being active and not active. Since 2001, it's been managed by a research center in Italy, and it's become a very active project. So GRASS has a different vocabulary and workflow, and it takes some getting used to. There's a thing called a GRASS database that you have to have your data in to work with GRASS. Originally, GRASS was a raster-based GIS, meaning it was only had tools for dealing with raster data. It's now become also a vector GIS with a huge suite of vector tools, including topology and networking and things like that. So it's an extremely powerful analytical package. Another thing was that historically it had no graphical user interface. It was all command line. And this was true for a lot of softwares. When I got into GIS originally, Esri's software was all command line as well. So this is just the development that a lot of things have gone through. Now there is a true Windows version of GRASS available with a nice graphical user interface. So it's become a much more user-friendly piece of software in recent years. You can use it to do cartography, kind of simple cartography. Cartography is not its strength. Really analysis and modeling is its strength, but it does have some tools for creating simple maps. It has a lot of tools for 3D visualization. You can do some really nice effects. It's really strong at image processing. It has hundreds of modules for dealing with satellite imagery and LiDAR and things like that. And on the vector side, you can do network analysis, you can do chart symbolization, vector geoprocessing like buffering, all the kind of simple things you're used to doing, it's going to have. So that's GRASS. Now we're going to move ahead and talk about this thing called Marble. It's essentially an open source Google Earth. It's a virtual globe and a world atlas, but it'll run on any operating system. There are desktop and mobile versions of it. It has a lot of different base maps that ship with it, including temperature and satellite and historic maps and things like that. You can use it for routing and geocoding. You can even, it actually will show satellite orbits and stars, and you can, I believe you can look at the moon on it as well and create animations with it. So here's what Marble looks like. I'm switching out the base map, twirling it around a little bit. You can set bookmarks, so I'm just zooming into Albuquerque, switching out base maps with some different options. So you could use it for a lot of the same sorts of things you can use Google Earth for. So it's an interesting little project. Saga GIS is a German piece of software, and it's really like GRASS, developed to do spatial analysis. It's available for Windows and Linux, and one of the nice things about this, you can access these tools through the toolbox in QGIS. So there's a Saga tool set in QGIS that you can use. Saga, like GRASS, has a different workflow, and it takes some time to learn how to use the piece of software. So you'll see that one of the powers of QGIS is that you can access some of these really powerful analytical softwares through QGIS without having to mess with learning another piece of software. Map Window GIS. This is kind of a standard desktop GIS. It was originally built in .NET and is for Windows only. Since 2015, they completely rebuilt it from scratch in C#. It was originally started out by this professor at the University of Utah, Daniel Arms. And it's not a super active project, especially when compared with QGIS. They haven't had a new version in the last 2 years. So it's not growing as fast as QGIS and has a smaller community, but it's still an interesting piece of software. This is what the latest version, version 5, looks like. You're going to have your table of contents on the left. I'm switching out base maps, turning layers off and on. It does have a toolbox too, so I'm turning on the toolbox here, and it has tools for doing different geoprocessing operations. So again, a very standard desktop GIS, just a not very active one. This brings us to Gvsig. This is an interesting project. It's part of the Java tribe, so it means it was written in Java. And this was originally developed by the town of Valencia, Spain, and it is available for Windows, Linux, Mac, and Android. But it's very multilingual, and it's very popular in Spain and Portugal and that part of the world. So it's really, I kind of think of it as a Spanish GIS. Not all the dialogues are completely in English, although that's gotten a lot better. You can basically choose the language pack that you want to have it translated into when you open it up, and it's translated into lots of different language. So it doesn't have a huge English-speaking user base, but it's a really powerful piece of software. It's under quite a bit more active development than Map Window, for example. It's worth keeping in the back of your mind. This is a map of New Mexico land ownership and counties, so you can kind of see what the Gvsig interface looks like. This brings us to QGIS. This is what we're going to be focusing on this semester quite a bit. It too is available for Windows, Linux, and Mac. In fact, there is also a data collection app based on QGIS called QField that runs on Android. It has a super active development community. There are new commits to QGIS daily. There are also, you can write your own plugins in QGIS using Python. So there's a huge community of plugin authors who write nice plugins for it. These are basically extra add-ons to the software, kind of like extensions in the ArcGIS world. It has a really active listserv. In Lab 1, I'm going to have you subscribe to that listserv and follow that during the semester. This is basically an email list, and you can get support if you have a problem. That's where your support is going to come from, by emailing the QGIS community, asking a question, and they are very responsive typically. You can also just follow it to see what kind of issues people are having. So it has generally a very intuitive interface. I know ArcGIS and QGIS so well that this isn't easy for me to judge, but having taught this class a number of times, students generally tell me they find QGIS to be more intuitive than ArcGIS. And it is true that there's a lot of things in QGIS that just require fewer clicks than in ArcMap. And as I mentioned or alluded to, QGIS can be used as a front end to GRASS tools and Saga tools and several other geoprocessing libraries. So it's kind of a one-stop shop for all these geoprocessing tools that are out there in the open source world. Here's an animation of using QGIS, and one of the things that requires fewer clicks is styling data. I'm opening up this thing called the styling dock on the right-hand side and just changing the classification of the population by counties, and the result just appears on the map instantaneously. There's no having to click OK or anything like that. So it's there are a lot of things like this that are really fantastic, and I think when we get into some of the data visualization cartography tools in QGIS, I expect it's going to blow your mind a little bit, because there's a lot of things you can do in QGIS that you can't do in ArcMap. So this is a slide talking about this application stack that QGIS has. So there's the core QGIS functionality. Underneath the hood, it's also using that software project ProjFor as the projection engine. It's using Google and Ogre to deal with raster and vector data, so reading, writing raster vector data in and out of QGIS. And because of this, QGIS will read and write far more file formats than ArcMap can, for example. So you can bring in KML and GPX files without having to import them because of that. GRASS and Saga are present in the toolbox in QGIS, so you can use all of those tools and your data doesn't have to be in a special format. You can use GRASS tools against a shapefile. And then you can also, it has support for this spatial database called PostJust that we're going to talk about. And this is an incredibly powerful environment that I'll talk about a little bit more in a few minutes. When you put this whole stack together, it's a really powerful package. Another thing that I added in here to talk about is RStats, because this is a really rapidly evolving environment. R is a programming language and an environment for statistical computing. There's a kind of a companion package called RStudio that lets you, it's like a graphical user interface for writing R code and doing things with it. R has packages for doing different things. They're kind of like plugins or extensions. And the number of packages for R, I don't have the exact statistics, but the ones that are focused on geospatial data has increased substantially over the last couple of years. So you can, if you're fluent in R, you can almost consider R as a standalone GIS. It will produce graphical output with this. There's a library called, or a package called ggplot that can be used to create images like the one you're seeing here. It will do animations and any kind of data cleanup or spatial analysis you can think of, you can accomplish in R. So we're not going to cover R because you could do a whole class on it, but I want you to just know about it. And if you're the kind of person who kind of gravitates towards wanting to code, this would be a great place to invest some time. The last thing I'll mention in terms of software is PostJust. We're going to do a lab on this in a few weeks. And PostJust extends this database called PostgreSQL, which is an open source database that is as powerful as any database out there, scalable, robust. And so what PostJust does is extends the Postgres database with spatial data support. So that means that you can import your spatial data into PostgreSQL with this PostJust extension. And one thing that Esri has never really captured is the real value of SQL. When you are in ArcMap and you're going to select records out of an attribute table, it really limits you just to the where clause part of a SQL statement. And we're going to see here how you can use SQL to do much more powerful things. What you're looking at in this little animation is the database manager in QGIS. So QGIS has a database manager, and I'm opening up project layers, and I have a vegetation shapefile here, and I'm previewing the table and previewing the geometry of this vegetation layer. And now I'm opening up the SQL window, and I have a saved SQL query, and this is basically going to create what you do for a summary table. It's going to calculate the total acres by vegetation type. So you can use SQL to do a lot of really powerful things. And beyond just getting information out of your database like this, you can also use spatial SQL. And PostJust comes with hundreds of spatial SQL functions. In fact, I think it's over 1,000 at this point. So there's a function for buffering, for example, a function for doing a union. So you can do all kinds of spatial operations on your data with SQL and PostJust, and it's very fast and very powerful. So those are the softwares I wanted to introduce, and now I'm going to introduce this organization called OsGeo, the Open Source Geospatial Foundation. It's a nonprofit, and their goal is supporting open source geospatial tools. So it's an all-volunteer organization, and the URL is there, osgeo.org. And one of the real functions it provides is financial, organizational, and legal support to individual open source projects. So this slide shows you all the projects under the OsGeo umbrella. So QGIS you'll see here under desktop applications. And so to become a project under OsGeo, the project goes through an incubation period where it's vetted for proper documentation, interoperability, a nice website, and things like that. And so once the project goes through its vetting process, then it becomes an OsGeo project and gets support from this organization. And a lot of the things we've already talked about are OsGeo projects: GRASS, QGIS, Marble, Gvsig, Google Ogre. What else do we talk about? PostJust, a lot of web mapping applications. So there's a lot there. So when I said there's not just one source for geospatial software, you're starting to see this now where there's a lot of really powerful packages out there that you can use. One way you can explore all this is this OsGeo Live. OsGeo Live is a little Linux operating system packaged with all the OsGeo software. So you can set this up on a bootable DVD or a bootable thumb drive, or build a virtual machine based on it, and just boot up off a DVD into OsGeo Live into this Linux environment and play with all of the different GIS software to try it out. It's all pre-configured. So it's a really powerful little package that you can use to play around with. Another service that OsGeo provides is this installer for Windows, OsGeo for Windows. So you can run this installer and install any of the OsGeo software onto your machine, and it will take care of any dependencies. And this is probably my favorite way to install QGIS on a Windows machine, because as we'll see, QGIS has many different versions, and you can install the current stable release, the long-term release, the nightly version of QGIS, all simultaneously, and use whichever one you want. So it's a really fantastic tool for installing software. Also, another reason I like it is if you want to update to the latest version of QGIS, you just rerun the installer and it does it for you. You don't have to uninstall and reinstall. Another project of OsGeo is GeoforAll, which is their educational wing. So this is a committee for education research, and they provide curriculum for teachers and things like that. And the last service that OsGeo provides, and probably the one people use the most, are conferences. So OsGeo organizes these conferences called FOSS4Gs, free and open source for geospatial. The first one was in 2003. And that's a younger me sitting there in this little workshop. It was very small, 125 attendees. There are now international events and regional events multiple times a year. There is a FOSS4G North America every year. This year in May, it was in St. Louis. You can go to the website. Often these conferences will record all the talks. So whether you can go or not, you can just go online often and find a video of a talk you wanted to hear without having to go to the conference. Every year there's also an international event. This past just a few weeks ago, it was held in Tanzania in Dar es Salaam, and it's held in the United States every 4 or 5 years. It was just in Boston last year, so it'll probably be a few more years till we get another one. So in conclusion, you can accomplish pretty much all your GIS, GIT needs with open source GIS. It's fun, it's a great community of people, and I really think it's a rising force. It's GIS ready to do real work on any size data. The weakness, I would say, 5 years ago used to be cartography, especially if I'm talking about QGIS. I think now QGIS has flipped that around to the point where cartography is one of its major strengths. And we're going to do a data visualization lab, and you'll see some of the really crazy powerful things you can do in QGIS. You do need to learn different software and workflows, so that's where this course comes in. Hopefully by the end of this course you feel comfortable in this environment and can keep exploring it. Because one of the things I'd like you to know is that ArcGIS is fantastic while you're in school and you get the free license, but as soon as you graduate, that software is going to go up and cost you thousands of dollars per year. So it really behooves you to learn how to use something like QGIS, which is going to be free for the rest of your career. So it's a fantastic thing. The strengths of open source GIS is its ability to read and write pretty much any geospatial format under the sun. All the open standards are followed, and there's just a lot of interoperability in these systems. There's obviously an economic gain by not having to pay huge license fees. And you can just reduce your dependence on proprietary vendors and become involved in a collaborative GIS community. So that's an overview of the open source GIS world, at least the desktop part of it. As you can see, there's a lot there. So what you can do for the rest of this week is start and finish Lab 1, which is basically going to just walk you through a lot of this, visiting websites for a lot of the softwares that we've talked about here and get you a little more solid footing. It's going to reinforce a lot of this lecture.